I converted some RV light fixtures from incandescent to LED, and to do that and to research it before I even built it, I had to have a light meter of sorts. And here's what I'm going to show you is a do-it-yourself light meter for free. Okay, here's a free light meter, and some of you may recognize this and some of you may not. It's a photocell from one of those standalone garden lights that are self-charging. The black area is the photovoltaic cell, and you can see two leads coming off that. The cell itself provides a voltage with light impinging on the photovoltaic cell, and with the two wires that are coming out of there, a voltage can be measured. Now that voltage normally charges a rechargeable battery in the light, and then it lights at night and shuts off during the day and recharges. This particular light was junk. It was free. The photocell still worked, so I converted it to a light meter of sorts for checking the voltage on produced by an incandescent bulb, and comparing that with an LED conversion. So I'll just hook that up and show you how that works. Okay, this light meter was built into a stand approximately 1 foot high, and you can see the photovoltaic cell at the top there pointing down. Coming out of that are two wires which come down here to the leads for a voltage meter, and I've got my voltmeter over here. You can see it's producing 1.55 volts in about that range right there. I'm going to take a flashlight with my other hand and put that up into the light. See the voltage climb there when the light's on? It drops when the light is off. So the voltmeter will read proportionately to the amount of light falling onto the photovoltaic cell. That's the secret of this. Okay, here's the setup, and I'm checking the voltage produced by this incandescent fixture from an RV. And I've got the leads on the photovoltaic cell going to my voltage meter. The voltage meter reads 2.0 volts, 2.01 volts, something like that. I've turned the shop lights down just so that it provides a reading for the light itself. Okay, we'll compare this with an LED fixture that I've converted. Okay, this LED or this RV light fixture has been converted to LEDs. You can see the LEDs in close-up. There's 48 LEDs in total. I'm going to put the diffuser back on, and we'll connect it to the battery and take a comparative reading like we did for the incandescent. Okay, here's exactly the same setup, but now we've got the LED fixture, converted fixture, hooked up to the same voltage source, which is a battery. 12.5 volts is about what it's reading. And I don't think it'll show up, but I'm just going to go and check the reading on the meter. The meter, if you can see that, is about 2.35, 2.36 volts, something in there. Okay, so there you have it. Incandescent fixture, single bulb, and 48 LEDs. The LEDs came out on top with a higher voltage produced of 2.37, and the incandescent light turned out about 2 volts. So the LED conversion is brighter, and for about 1/8 of the power usage. Now the light meter is what I use to do these crude checks before I actually converted a light fixture, so I could get an idea of how many LEDs would produce how much light. So once again, the stand that I've got there, you can see the top of the garden fixture, and in that is the photovoltaic cell, and two wires out of that connected to a voltmeter will give you a relative voltage reading depending on the light impinging on the photovoltaic cell. Now, it's a crude light meter, but it allowed me to do some relative comparisons to decide that switching over to LEDs and how many, that's what led my project ahead. And the purpose of all of this, for me, on this occasion anyway, was to produce a changeover from incandescent to LED light. And that's going quite well. I've converted almost all the fixtures in the RV, and this free light meter allowed me to do that. There's no real scale other than voltage. You could probably put a light meter alongside it and calibrate it, get a better idea if you're a light meter type of guy, and I'm not. I just needed some comparative readings. So there you have it. And if it isn't free, it's going to be cheap. You can buy these things for about $3 at your local big box store. Just disassemble it, chuck away what you don't need, and you can make a light meter for yourself. All you need beyond that is your volt ohm meter. Okay, that's the conclusion. I hope that helps anybody who wants to come up with either the same experiments that I did for changing over the lights, or needs a relatively crude light meter. There you have it. Cheers.